Alright, let's try this part 2. I'm actually having to do a second tape because, oops, I accidentally pressed the stop button when I meant to press resume. Anyways, let's look at the spring semester review part 4. So here are some formulas that you would need. Volume for a prism, cylinder, pyramid, and cone. Notice here also got sphere, surface area, and volume. But again, we will get to some more surface area stuff in a second. So, anyways, whoops, meant to go fast, not that far. Okay, so the first one's find the volume of a cube. Let's keep in mind that here we've got 5 and 5 on each side. So really what I'm saying, for the area of the base is like this front face, that would be 5 times 5, which is 25. Okay, and the height of the prism is also going to be 5. So all you got to do to get the volume is 25 times 5, which would give you 125 centimeters cubed. Okay, excuse me, for the volume of a pyramid, we're going to say the base here is 36, because 6 times 6 is 36, and the height is 7, so then I can do 1/3 of 36 times 7, and that would give me my answer of 288. I'm sorry, not 288, 84, I'm thinking something else. Alright, now let's look at 54, because we're going to do this in terms of pi, why not? Volume is equal to pi times radius squared times the height. So radius squared is 3 squared is 9, 9 times 9 is 81, and then you would have 81 pi. Now, if you needed to round that off, you could do 81 times what pi is, 3.14, to get like 240 something. But in this case, they were just asking for it in terms of pi because, well, again, somebody was really determined with pi. Okay, so let's look at number 55. 55 is the same thing, except it is a cone, so it's 1/3. And when we do that one, same thing again in terms of pi. We end up with 1,400 pi centimeters cubed. Sphere, we have a volume, which we're going to say is 4/3 pi times 6 cubed. You can see how I did that. Again, notice all I'm doing is 4/3 times 6 cubed. When it says in terms of pi, you just add the pi on the end. If you have to multiply that out, well, then you multiply it out. And if you're not sure, I'll let y'all know before I'll look at the exam and I'll let y'all know ahead of time. So, the next one, 4 pi r squared. Oh, there's the surface area, and there you go. Alright, so now we're at 58. 58 is kind of an interesting one. You have a large cylinder, and we're going to find the surface area of the large cylinder. I'm going to say here LC, which has so that surface area again is pi times the radius, which in this case is 12, times the height, which is 25. Plus 2, this one I'm going to be nervous about, 2 pi r squared. So 12 squared. Okay, that would give us the whole thing. But there's a small cylinder that is being cut out. And this is where this gets kind of interesting. So the small cylinder, I'm going to say is SC, is pi times 5 times that height, which is 10, plus, we don't want both, we just want one. Okay, so we're going to do it this way. So, I'm still going to say 2 pi h. 2 pi r squared, 5 squared. Okay. That would give me the surface area of one, that would give me the surface area of the other. And this time, though, that surface area kind of extends out. So you're actually going to end up adding these two together. That's going to get you pretty close to the answer. Is this in terms of pi? No, thankfully not. Okay, so let me pause and type this into my calculator. Okay, now, because this one, like the way it goes in, you've got this one going down in, you would end up, that's actually more surface area that you've got going on here. So what we want to do here is, since that's more surface area that you've got right in there, then what we're going to do is we're going to end up adding those two together. And so when I do that, plus 1,847.26, like I said, that should get you pretty close to the answer. Okay. Thing is, though, is that this section right up here doesn't need to be up there. You would be adding subtracting that from like the total because you're bringing this down like that. So really we should take out a pi minus a pi times 5 squared and get 2,000. So finally I'm subtracting this pi times 5 squared, one circle, to get 2082.88. That should be the final answer, and it should be really close. I'm not too big of a fan of that. We'll see if that ends up on the test. All right, number 59, part A. Okay, let's label this. Let me take a picture. Use this one full screen. So which ones are chords? Oh, which describes EF. So EF is this right here. It goes through the thing, so that would make it a secant. Okay, so here's an example of a secant. This one right here, GJ, would be an example of a tangent. CD is a diameter, or also known as a chord. Okay, so keep in mind, chords are like AB and CD. The diameter is also a chord. Okay, so keep that in mind. And then your radius would be like well, if I put another point here, let's say HI, CI, or ID. I technically should have gone IC and ID. But you get some ideas there. I just wanted to make sure y'all understand all the different things of what those are, what the vocabulary terms are there. All right, so let's move on to number 60. I am not sure exactly when I paused, and I guess I kept talking and didn't realize I had finished. So hopefully, I want to make sure I got y'all here for these, as I'm describing these. Make sure that was in there. I'll go back and watch my video. If I need to go back over things, I'll go back over things. But over here, I said that, well, these two lines are tangent, so these were equal. So again, you could use the numerical solve to solve this right here. Or you could just do variables to the left, numbers to the right, you'll get x equals 5. But you got to put that 5 back in place of the x here and say 3 times 5 is 15 plus 3 is 18. So that's 18 units. Now on 61, I did here, I said, okay, if this is 20 degrees, then so's here. And then I did 20 plus 90 to get 110. Okay, so now let's look at number 62. Alright, so I wanted to make sure on this. Now there's a rule that says if this is the radius, then obviously if this is the radius 5, then here's the radius also here, 5. Okay, and then you could do Pythagorean theorem to find out this is 4. And if this is 4, this is also going to be 4 because it's being bisected. And so then DB is 8. So this is kind of a long way to get to something that should be hopefully fairly easy. We did it a little bit differently, but there you go. Alright, so let's look at number 63. I'm just going to give you the drawing for that one. Find the area of segment DFE. So I'm presuming that this right here, here's E, here's F, here's D, and they want this right here. I'm presuming this is what they want. Alright, so the area of that segment, DFE, that doesn't make sense. That should be the triangle. Okay, so that's 12, and that ends up being 72? I'm going with triangle DFE. I'll look into that and make sure that's what they meant, because that is actually kind of a weirdly worded question. Or did they mean this area in here? And if they did, then that's a whole different story, and we'll look into that. Segment of a circle. I personally think, okay, so let's do this. Triangle DFE is going to be 72. Okay? This is a fourth of a circle. So if I do 1/4 pi r squared, so pi times 12 squared, I get, say, what do I get? I get 113.10. So if they ask for the triangle, that's your answer. But if they wanted this section right in here, then you would have to actually subtract those two, so minus the 72, and you would get that this right here is equal to 41.1. Okay? And that's, I mean, without knowing it better, that would probably be the answer they were looking for. since they're saying segment and not say the triangle, that's what I'm going to bet that's what they're doing. All right. Again, so here's another formula that we need. Area of a sector, or sector area, I guess you could say. That's the one where we did the degree over 360 times pi times r squared. Okay, if they ask for arc length, degree over 360 times pi times 2 times the radius. Okay, something like that. All right, so they want the area of this one, DEF, which is a little bit better. So number 64, I would have just done 80 over 360 times pi times 3 squared and press enter and see what I've got. So let's see here, 80 divided by 360 times pi times 3 squared, and I get 6.28. So here, approximately 6.28 centimeters cubed. Oh, we want the answer in terms of pi, because again, why not? So let's do this. 80 divided by 360 times 9, and I get 2. Okay, so this is what I got if I just typed in pi, but if I didn't, it would have been 2 pi. Okay, this whole terms of pi thing is starting to get annoying. Find the length of JK. Arc JK. Okay, so number 65 is arc length. Okay, so we're going to do 72 degrees, 72 over 360. So we're using this formula here, times pi times 2 times 5. Okay, now keep in mind, if I did 72 divided by 360, I get 1/5 times, say, 2 times 5. That would give me just 2. So this one would give me 2 pi. This one was square, centimeters squared. This one would have just been centimeters. But again, if I type that into the calculator, I would have gotten 6.28 centimeters. Okay, and again, keep in mind arc length is just how much we go around. Okay, so now we're starting to get into, say, our last test, where we were talking about like the different shapes or different formulas that you would use for the I forgot how to say it, for the different circles. Take some pictures from the old one because I can see it right here, and y'all can hopefully work with that. So here we go. Picture number 1 from my computer screen. I would tell you this is from video, or this is from the Unit 14 video. So if you want a better picture, then go to that. Here's picture number 2. You can pause again, maybe get some of this stuff down that you would need. And now let's do picture number 3. Okay, so now you can see picture number 3. And again, you notice here I had a lot of stuff that was covered here. So we'll try to cover what we can. But let's see what we've got. So keep in mind, if we go from like a point that's like right on the edge of the circle to an arc length that's like out there, you can say multiply by 2, but if you're going back in, we're going to divide by 2, and that's shown here in this one right here, the multiply and divide by 2. So if I divide that 120 by 2, I get 60 degrees. Now, keep that in mind that this is an arc, or this is like half a circle, so that means from here to here is 180 degrees. So if I do that same idea and divide by 2, that means this is 90. So now I've got 4x plus 10 equals 90. This is like a simple problem that you can work with, and then you would subtract and divide, and you would end up getting x is equal to 20. Okay, so there are some problems that look like they could be more difficult, and they really shouldn't be. Here's another one. Again, notice how this is on the line. This is the circle around. I actually made y'all do the slightly more difficult version where you still had to subtract this from 360, then divide by 2. But all you got to do is divide by 2, and you find out that's 120 degrees because you just had to say 240 divided by 2. Take half. All right. When you want the one that's on the inside, remember, we have to see what we do here. Okay, on these type of problems, this is the one where going back to here, and let me find the formula. It's this one right here, and we're saying 1/2 of the two angle measures. So if I add these two together, I'm saying 1/2 of 110 plus 40, and when I do that, I would get that angle 1, measurement of angle 1 is equal to 75 degrees. Okay, moving on. Notice on this one, when we have it on the outside, we want to subtract. So I'm going to say 1/2 of 65 minus 25. And so when I do that, I would get that the measurement, or x, the measurement of angle x is equal to, that's going to be 40, half of that is 20 degrees. Okay, so now the next one, remember this times this, 2 times 8 is equal to these two, 4 times x. So that means 4x is equal to 16, so x is equal to 4. Okay, fairly simple. And again, it's just using these little concepts right here. Here's the one with two chords, and the one that where I said subtract to secants right here. That was from the previous problem. Okay, so we're getting close to the finishing line here. And now let's go to number 72 and 73. Okay, so 72, I'm just going to kind of make sure you see that. Okay, so this is the one where we had something like, we had to add these two together. So we had to add these two together and say 6 plus x. So it was the outside times the sum equals the outside times the sum. So in this case, that would have been 5 plus 7, because 5 plus 7 is 12. Okay, and again, you could do the numerical solver on this, but you would have ended up with, say, 6x plus 36 is equal to 60. And then if you subtract and say, you would get x equals 4. So the length of JG, darn. Okay, I would have been happy at x equals 4. But even if you did numerical solve, you should have gotten 4. You still have to plug that in here and say, okay, 4 plus 6 is 10, because they wanted the length of the line. This one, don't forget, was supposed to be this one squared equals, so x squared is equal to, we got to add, again, always keep in mind you got to add, so that's 8, the outside times the inside, I'm sorry, the sum. Oh, that was the worst looking, okay, so try that. So that means x squared is equal to 16, and then you could take the square root and get 4. Okay, so easy peasy, nothing really that hard. Alright, number 74. Okay, again, don't forget that you're saying, what is the equation of a circle? When you're looking at this, minus 3 squared, that was horrible. Okay, y minus 5 squared equals 25. Okay, keep in mind, opposite of these numbers, so the center is at 3, 5, and then take the square root of the equals, and that's your radius, and that would be 5. Okay, so what does that mean? That means that if I move over here and go 1, 2, 3, 4, or 1, 2, 3, 1, 2, 3, 4, 5, I have a point here. I would go 5 down, 5 across, 5 across, 1, 2, 3, 4, 5, and 5 up, 1, 2, 3, 4, 5, 6, 7, 8, something like that. And connect those, and I would have a circle. That's the worst drawn circle, but that's why I don't do that. Alright. And then we start getting into things that we haven't talked about too much. 75, 76, 77. We will look at those, 78, 79, 80, and I will talk some more stuff about what's on the actual test. Because I think some of those at the end, that's when we're starting to deviate from what we've seen and what is on the test. Anyways, that is it for today, guys. I am pretty much done with the review. I will discuss some more in class, but I am done. Thank you so much for your time. Thank you so much for everything else. I hope you've really picked up on something here, and I hope I've really helped y'all a lot. Anyways, y'all take care. Thank you so much for your time.